Hello and welcome to another logic lesson. This time we are talking about the law of syllogism. In a different video I talked about the law of detachment. This is law of syllogism. It's a little longer in what it looks like, but it makes just as much sense. I don't know. To me it makes sense. I like this one better, to be honest. Law of syllogism. It allows you to draw a conclusion from two different conditionals. So if you remember with detachment, we just had two lines of writing, right? If P, then Q, P, and then our therefore was Q. This time we're actually going to have three lines. We're going to have an if P, then Q, an if Q, then R, and then we're going to have another conclusion. So this is actually going to be a little bit more letters. So allows you to draw a conclusion from two conditional statements in which the conclusion of the first is the hypothesis of the second. So I'll do the symbolic map in a second, but to be honest, this makes a little more sense to me when I write it horizontally. So I'm going to do the same for you guys. It looks something like this. If you have P, then Q. And what this says is the conclusion of the first one is the hypothesis of the second one. So it's when those two ones in the middle match, right? If P, then Q, if Q, then R. What the law of syllogism says is that you can skip the middleman, so to speak, and just go straight from P to R. Kind of like if these two things were to overlap and you smash them together. If P, then Q. So if Q, then R, you can just go straight there. That's what it is saying. That is the law of syllogism. Excuse me. So writing it vertically would just be if P, then Q. If Q, then R, and then our therefore. So do you remember what the symbol for therefore is? Therefore, if P, then R. So your conclusion is longer than the law of detachment. If P, then Q, if Q, then R, so if P, then R. The reason for that is like if P happens, then according to the law of detachment, that means Q has to happen. So if P is true, then Q is true. But if Q is true, then R is true. So if P is true, that means Q is true, that means R is true. So this whole kind of domino effect kind of happens. If P, then Q. If Q, then R. So as long as that first P thing happens, then R is going to happen. Because technically this can happen more than one time. Some things you might see are like if P, then Q, if Q, then R, if R, then S, if S, then T, etc. And you can keep going like that. And like, well, what's the conclusion? And well, if P happens, then that means Q happens. And if Q happens, that means R happens. And if R happens, then S happens. Then if S happens, then T happens. You could just skip everything and go straight from P to T. Because if P happens, then there's this whole like domino effect going on. Like P goes to Q, goes to R, goes to S, goes to T, that kind of thing, right? P goes to Q, Q goes to R, R goes to S, S goes to T. That just means it gets to go there. So as long as these ones match, you can just go straight across, right? These ones matched, so you could just go straight across. These ones match, so you could just go straight across. So something like that. As I said, the two we're doing in this course is law of detachment and law of syllogism, which means that anything else is once going to be the no valid conclusion thing. If it's anything else. So this time what we're checking is to make sure that the conclusion of the first is the same thing as the hypothesis of the second. So if it is Saturday, then Jake has a baseball tournament. So Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. So it looks like it is working. The second half is matching the first half, right? The second half is matching the first half of these two things, which means your conclusion is going to be, if it is Saturday, then he will need to pack his lunch. And I'm just going to write that down. If it is Saturday, then he will need to pack his lunch. Yeah, I didn't even read the whole thing, really. You don't need to. For logic, it's all about whether the sentence structure makes sense rather than whether what is being said is true or not. So if it is Saturday, then Jake has a baseball tournament. And if he has a baseball tournament, he's going to need to pack a lunch. So if it's Saturday, he needs to pack his lunch. There you go. For the next one, if a number is divisible by 12, it's divisible by 6. If it's divisible by 6, it's divisible by 3. So to check the law of syllogism, you want to make sure the second half of this one is matching the first part of this one. So I highlighted them, and either they match or they don't. So do they match or do they not match? And in this case, they match. It's divisible by 6. A number is divisible by 6. So they match. This is law of syllogism. So if a number is divisible by 12, then it is divisible by 3. If a number is divisible by 12, then it is divisible by 3. Which is true, by the way. If 12 goes into a number, then so does 6, because 6 goes into 12. And if something's divisible by 6, then it's divisible by 3, because 3 goes into 6. So, transitive property is another thing we kind of used with equal signs. It's very similar. If a number is divisible by 12, 3 goes into 12, so it goes into the whole thing. So, don't know if you know this, but the way you can tell if a number is divisible by 3 is if you add up the digits of the number and 3 goes into that, then 3 goes into the whole number. That's kind of a shortcut way. And if it's also even, that means 6 goes into it, because if 3 goes into a number and 2 goes into a number, it's divisible by 6. So there's some SAT skills for you. Next up, once again, I would suggest kind of like looking through these, pause the video, look through them, see if you're like, okay, that one is, that one is, that one's not, that one is, that one's not, that one's not, whatever. See if you can see whether it is or is not. Otherwise, here I go. First of all, I guess I'll start talking about, on a test or quiz, I'm not going to say, is this the law of syllogism or not? Is this the law of detachment or not? I'm going to say, is this the law of syllogism, detachment, or no valid conclusion? So you do need to start thinking about telling that it's not the law of detachment nor the law of syllogism, because these questions would just kind of like be randomized put together. So like a way you could figure that out is just to see if both of them are if-then statements. If they are both if-then statements, then it can't be the law of detachment. It doesn't make sense, because the law of detachment only had a statement for the first part or the second part, it didn't have an arrow, so there's no if-then statement. So that's one way you can tell them apart. Law of detachment does not have an if-then for the second part, whereas the law of syllogism does have an if-then for the second part. So detachment has only one, syllogism has two. So I would just look through these and I would note that these are both if-then, so maybe it's the law of syllogism. This is an if, these are both thens, so this could be the law of syllogism. These are both if-thens, these are both if-thens, right? Then. So this could be the law of syllogism or nothing, right? It's that or nothing. But none of these could be law of detachment because it has an if-then in the second line. Which means for every single one of these things, I'm going to go, does the second part match the first part? Does the second part match the first part? Does the second part, boop, match the first part? Boop, does the second part, boop, match the first part? Boop. And after singing that song, because that's what I do, you're just going to say yes or no. And if it's yes, you write the answer. And if it's no, you write no. So let's see. Rectangle, check. Boating, oopsie. You will go boating. It's sunny. Nope. You will use your target red card. You will not use, you will use versus you do not use. So that's nope. They do not match. School would be canceled. School is canceled. Those do in fact check out. So for this, I would say yes, it is the law of syllogism would be my answer. This would be no valid conclusion. This would be no valid conclusion. This would be law of syllogism. And I'm lazy, so I don't write out the words. And then, the ones that do work out, you have to write the sentences. So, actually, I'll do it like that. Okay, so if a quadrilateral is a square, I'm just going to do this fast so the video isn't too long. Then it has 4 right angles. No valid, law of syllogism. So if it snows, then students etc. to make up a day of school. Probably not this year though, right? We're already learning at home. And there you go. That's the answers to this one. When it's no valid conclusion, you don't have to write a conclusion because there is no valid conclusion. So you would literally just write that. No valid conclusion. All right, hopefully that makes sense. Like I said, make sure you are trying to be able to tell apart the law of syllogism and the law of detachment of when to use which. Like in this one, if you notice, none of them had an if-then statement for the second one, right? So like if I saw if-then, but the second one is not if-then, then this means this has to be law of detachment or nothing. This did not have an if-then, so it's law of detachment or nothing. The second one is not an if-then, so it's law of detachment or nothing, etc., etc. None of these could have been law of syllogism because both of them were not if-then statements. Only one of them was. Okay, that's it. It's almost 15 minutes, so I'm signing out. Have a good one.